So happy to be here. Sue and I, yes, Sue, we have known each other for, I don't know, a couple of months or something. It's fine. No, more than that. Today I'm going to talk about Kusto, and then some of you might say, what is Kusto? But you will know when we're done. And I will also talk about Power BI. Hopefully you won't ask what Power BI is. If you have any Power BI questions, I'm not the Power BI expert here, so bear with me there. But I know the power between Kusto and Power BI, how that works, and I know how to make it work even for you, even though if you haven't tried it before or know how to get the best out of it. You will know that when we're done today. A small thing about me. My name is Brian. I'm from Denmark. If you would like to try to pronounce my last name, my full name is Brian Bønk Rueløkke. Good luck. I'm a data geek, and I'm also a Microsoft MVP on the data platform. If you want to follow along, I am on LinkedIn. I try to be there once a day at least to post something. I have a blog on decode.bi, and I have a GitHub account where you can find all the slides from today if you need them. Christina, is that someone I know? Christina Ferris. Oh, hi, Christina. Sorry. Long time no see. And I just started my YouTube channel. It has one video, and if you come back tomorrow, you will find the second video. It is published, but not officially there yet. So if you would like to see something about real-time intelligence, then the YouTube channel is where to be. I'm also a fast-track predictive solution architect on Power BI from Microsoft and a Microsoft certified trainer for like forever. That's fine. Enough about me. What are we going to talk about today? Well, I will introduce you to real-time intelligence and Kusto in Fabric. What is it? What is the history about it and how to get started? I will dive into the history of Kusto. Why does it have that name? And why did the product group choose that name? That also has a small funny story to it. I will show you the Fabric experience. What is real-time intelligence inside Fabric? You can also buy this service outside of Fabric. Then it's just called Azure Data Explorer. And you can't buy it as a capacity outside of Fabric. You need to buy it as predefined virtual machines, and at least 2 of them. So you could imagine the cost there would be a bit more than in Fabric. So a demonstration, hopefully it will fly. I hope so. And lastly, a bit of perspective and patterns on where could this be done and how could I use it and to what means does it fit into an existing data platform today. But first of all, what is real-time intelligence and Kusto? This slide. We have a world today where we are the data volumes around us are exploding. You all have at least 1 or 2 devices that streams data live. You have a phone, a mobile phone that streams data live to some server in the world, even though you're using Apple or a Google phone or something, it streams telemetry to a server in the world. If you have a smartwatch, that also streams data. If you have a modern car, that also streams data every time you run it or drive in it. We have windmills that streams data. We have devices all over the place that streams data to us today. Oh, thank you, Aurora. This is where real-time intelligence comes to play because all this streaming data needs to be somewhere, and that is where the Kusto engine emerges and help us there. Imagine you have a windmill. That windmill has a lot of sensors on it, how much energy it produces, how much the wind is, temperature, how fast the wings are turning and all that stuff. And imagine you want, hopefully, you want the wings to be attached to that windmill, but one of the sensors reacts now and sends a message that, hey, this bearing is about to go haywire. Please change it before the wing falls off. Imagine that being done in a data warehouse today. Then you will have to wait perhaps an hour, perhaps 2 hours, or even 3 hours before that message emerges to the end user. With real-time intelligence, you can get that message through to the end user and to the service technician within a few milliseconds. This is where real-time intelligence really flourishes. And even though you don't notice this, you are all exposed to real-time intelligence today, perhaps not from Microsoft, but the schema of real-time intelligence from an airport. Airports are using real-time intelligence big time to try to move people around in the airport, because it is way more cost efficient to have you wandering around in all the shops and use all your money than having you hang around out at the gates. They are using live tracking from cameras and from pressure sensors in the floor to figure out how many people do we have where. That is real-time intelligence. They also use it in the security departments for all the scanners and all your luggage to figure out where is the highest pressure right now, and then they need to react to that instantly. They can't wait for the data warehouse to update. They need it now. But no matter how much we talk about real-time intelligence, it all starts with data. And all the data I've been talking about now is called telemetry. So every time you do something, a message is sent somewhere, and that message is called a telemetry message. If you ever stumble upon some of these buzzwords in this globe, logs, time series, IoT device, events, CM, security, and all that stuff, then you are a possible candidate to use real-time intelligence. This is not a complete list, but some of them. Microsoft did a guess of how many devices would be connected to the internet by 2025. 75 billion devices, and this is not a server or a physical server with a physical device with a net cable in it. It is streaming devices with a phone, a smartwatch, whatever you have, things I just talked about. All of these devices need to stream some sort of data. The estimate is that in the same period of time, so next year, we will be streaming a total of 90 zettabytes. That's a lot of data. All of this data needs to be stored somewhere. That is where the Kusto engine comes into play. I see a lot of chats here. I don't hope it. If I missed a question, Sue, please talk to me.
You haven't. We're just we're talking about your presentation, but not with questions. So it's quite a chatty group.
That's fine. That's fine. Just keep chatting. That's fine.
Yeah.
I love it. But before we dive into the technology, let me give you a short introduction to the history of Kusto. The history of Kusto has been around us for many years, even though you don't notice it. If you have tried Azure Sentinel, if you have tried Log Analytics, Azure Graph, Microsoft Defender, or the very small product from Microsoft called CM Pivot, then you have already used the Kusto engine. The Kusto engine is the supporting engine for all of these services. This is not the complete list, but some of them. And also know that Microsoft is its own largest client or consumer of the Kusto engine, which is supporting all of these services, because Microsoft is also using Log Analytics for internal logging. They are also using Microsoft Defender for internal defending from Azure and all that stuff. So the Kusto engine and the power there is used widely within Microsoft. But why is it called Kusto? Sue knows this answer because she was with me a few months ago. But it actually originates from Jacques Cousteau, who lived his life under the sea. He was the first to invent the breathing things that we have on our backs today. And Cousteau is French, and in order to translate that into English, it was just called Kusto. That is where we are today. The reason why Kusto was selected was that 3 of the founders of the Kusto team in Microsoft was actually was experienced divers, and they of course they knew the history around Jacques Cousteau, and they needed some sort of name for this product, and So they tried to translate that Jacques Cousteau, he explored the world beneath the ocean. And then with Kusto, you can explore the world of data. But is it good? Is it bad? I don't know, but it's still Kusto. There you go. Kusto has some capabilities. I won't go through all of them. You can get it from the slides when you get it from GitHub. But whatever data set you have, you can stream to it. Structured, semi-structured, unstructured, free text, whatever data set you have, the Kusto engine can absorb it to you. You can do near real-time streaming data, as I just talked about with the windmill. If the wind is about, if one of the wings is about to break off, then it will send a notification to you. If you have ever worked with a time series database outside of Microsoft, this is the go-to service from the time series database. And I almost forgot to tell you that KQL is even more a shortening. It's called the Kusto query language. It is the language we're using to address the engine with our queries. Do you need to learn another language? Yes, but no. Yes and no. I'll show you that in a minute, a small cliffhanger there. Whatever you're doing, everything is indexed and partitioned. This is why we get such a blazing performance. Normally, I use a larger data set than I have available today. I only have 31 million rows. Normally, I have more than 5 billion rows. And yeah, unforeseen circumstances made me just have 31 million rows. I hope that still blows your mind around how much data I can actually handle inside Power BI. I'll get back to that later. You can try it all for free if you want. Azure Data Explorer, dataexplorer.azure.com/free cluster. You get a cluster with, I think it's 1 or 2 gigabytes of storage space. That is quite enough because storage is compressed with a factor between 6 and 10. So you have enough data there to get started. And if you want to learn it, Microsoft has released a few years back perhaps the best gamification to learn the Kusto language called detective.kusto.io, the Kusto Detective Agency. It has 2 seasons and a Christmas season. And if you want to play with it, please start at season 1 because it has a storyline to it from season 1 to season 2 and on to the Christmas edition. And Sue is still on season 1. Great. Just keep on trucking and you will get there eventually. So what about the Fabric experience? All of this is pretty nice, but can I also use it inside Fabric? Yes, of course you can. When Fabric was released more than 1 year ago, we saw this image with real-time analytics at that point and data activator with one leg in the bottom of. At last build, the last build we just did a few months ago, all these things was merged into a new product called Real-Time Intelligence. Now we no longer have Data Activator. That is a part of Real-Time Intelligence suite. And we was added the Real-Time Hub. I will not dive into the Real-Time Hub today. If you would like to see it, I did a session on this Saturday at the Fabric Cafe. It is already live on YouTube. And you can see what the Real-Time Hub is all about. It is a free product from Microsoft, free because everything you create in the Real-Time Hub is actually built. But as long as you just use it and read from it and so forth, it is completely free. So what does all of this real-time intelligence actually do? Well, it enables you to do a lot of things. You can do event ingestion. Whenever you have an event, you can ingest that and store it and begin to react to it. You can do real-time analytics. And this is not real time because we are now into a philosophical discussion of what is real time. So I like to say it is near real time because every time an event happens, time has gone by. But let's not go down that way path today. You can do dashboards. At Build, we just got a hold of real time dashboards where we can do dashboarding in real time and don't have to wait for Power BI to refresh every 30 seconds. I have a session on that on YouTube. You can find it. Just search real-time dashboards on YouTube, and you will find Devang from Microsoft and me on a session today together, talking about the dashboarding. We have a 2-part session there, each of, I don't know, 45 minutes or something like that. Triggers, we can react to the events. So the windmill again, if the bearing is sending strange noises, then we can react to it as a trigger, and then that trigger can send us a Teams message, a mail message, or start another process, a pipeline or a Python notebook or something, whatever you need. We can do real-time AI. So every time a row enters the database, we can have that scored towards an AI model. And then the results of that AI model can be saved into the database within a few milliseconds, and then we're good to go. Applications, of course, if you need to build application on top of this, it can be done. I see that people are asking for links for the real-time dashboarding. It is Marte and her user group that is called, what is that called? Okay, Sue is getting it. Great. Thank you, Sue. And the last thing, of course, we can do event-driven actions. We can send events onwards and we can get things up and rolling. Again, you don't need to do screenshots here. All the slides are available in GitHub later on today. Just wait, it's fine. Sit back and enjoy the show here. This could be a possible architectural drawing on a high-level basis of how we use the Kusto database or real-time intelligence in Fabric. Let me see if I can find my pointer. It's that one. To our left, we have the data storage. We have the lakehouse, the warehouse, structured, unstructured data, whatever data we have. Then we can, in different ways, attach that data or put that data, ingest that data. There you go, diagnosing data. Thank you. In the link. The links are available now in the chat. Diagnosing data with Devang and I. We have a two-part session. Please look at the first one first because we have a connection there. Then you can store all of this data in your Kusto database. On top of this Kusto database, there is a so-called event house that is just the server for your database. And this data can then be exposed in the OneLake via through a live copy. All of this data can be exposed through Power BI, through a Kusto query set, which is just actually a view from the SQL world on the Kusto engine. And we can work with it in a notebook or wherever we need to do it. And I need to change the slide again. So now, here we go. Are you ready? I am. The built-in connector for Power BI is blazingly fast when working with Kusto data. This is for one reason. I think there's more reasons, but one of the major reasons is that the product team behind Kusto actually built the connector to Power BI, not the other way around. It was not the Power BI team building the connector to Power BI from the other sources. It was actually the Kusto team building the connector to Power BI. So they know how the Kusto engine works, and they know how to send that onwards into Power BI. It is blazingly fast to query the data, and it is also blazingly fast to do the calculations. I will show you this in a minute. And now you need to sit down. If you are standing, please sit, because everything you know about query performance versus data type, please forget that when working with Kusto engine. Data modeling is not a thing. We don't do that. We don't do best practices around data types. We don't do best practices around joins. Joins on a string is actually faster than joins on an int, on an integer. Sorry for that. This is because of the proprietary way that where the Kusto engine is handling all your data. To give you some of examples, single table reporting can be a good option. We don't have to normalize things. We don't have to put in the facts and dimensions and a dimension on that and then denormalize it when putting it to Power BI. One broad table with hundreds of columns, that's quite fine when working with Kusto. If you really need to do a data model, then you can't come around the many-to-many relationships, because I'll show you this in a minute. The Power BI is only reading the metadata from the Kusto engine, and then it cannot distinctive select which column has unique rows and values. So it will just fall back to many-to-many. That's quite fine, because everything you are doing is being handled by the Kusto engine. If you have dimensions, you need to tag them. Then you help Power BI to perform the the best query behind the scenes, because dimension filtering and so forth, we would like to have that at the top of the query. That's fine. If you have dimensions smaller than 1 million rows, it might be a good option to do a hybrid model where you have both direct query models and import, because then it might be faster for you if you really need dimensions. As I said, integer and decimals are slow joins compared to strings. That's just the way it is. Just accept it. And yes, Takami, you're starting data modeling now. If you plan to work only with real-time intelligence, you don't have to do that. But still do data modeling if you plan to do other things than real-time intelligence. So it's still a good thing to learn, Takami. If you are as old as I am, then you know this guy. It's called He-Man. I love He-Man. At a session, was that in SQL Bits? I can't remember. I actually did what He-Man did. So by the power of Grayskull, he shouts, but I'll do it as the power of Power BI. So yeah, exactly. I have the power. Thank you, Christina. So Power BI is excellent at building the KQL for you, either in a Power Query, I'll show you that, or by using DAX. DAX is also query folding back to Kusto, so that's quite fine to write DAX. But that's just the way it is. Or build a Kusto function. I'll show you all of this in a minute. Are you ready to begin the show? Let me show you this. Here I am in Fabric. Right now I can't see the chat, so Sue, shout if you have questions, right? This is my Fabric installment. I've created a workspace called Real-Time Analytics. It might be corrected to call it Real-Time Intelligence, but yeah. Bear with me there. I have created an event house that contains 2 databases. The database I will use today is called KQL database. I tend to name my things what they are in demo purposes, because then I can always find them. I will also jump into a KQL query set, and I will show you how I have loaded all the data to this database. Last things first. Hopefully this will fly. There you go. I have created an event stream. This is not an event stream session, so just accept that I have built an event stream that takes the demo data set from Microsoft called New York City Taxi. I've not done anything to it other than putting it into the KQL database and this table I just talked about. This is streaming live now as I speak, but the data is not live. This was just ingested at this time. I am 1 hour ahead of you guys in the UK. And look, the date time column right here is from 2022, but the data is still coming in live to the database. Let me close all of this. The database is this one, the KQL database. It is a part of an event house, which I just called event house. You can see the name right here, event house. So don't be mistaken. This is my name of my event house, not what you will call your event house, hopefully. In this event house, I have 2 databases. The KDA database, this is the Kusto Detective Agency. This is where I play around with the funny things from the Detective Agency, the gamification I just talked about. And I have the KQL database, which contains this table called New York City Taxi. The New York City Taxi table contains 31 million rows, and in the last 24 hours, it has ingested 2.8 million rows. Normally, I do this demo with billions of rows, but yeah, just accept 31 million rows. I hope that's fine. What else? Yes, this one over here. As I told you, if you get the free cluster, you get 2 gigabytes of data storage. That is quite fine because I have 31 million rows and I am only storing, I'm only storing plus 700 megabytes of data because data is compressed in a factor of 9.2. So the original data size was 6.7 gigabyte. It is compressed in a factor of 9.2 and are now only around 730.
So there's a question.
Yeah, go ahead.
What's the upper limit?
Of what?
I presume data that you can bring in?
I haven't seen that limit breached yet.
Yeah. Yeah, that was the question.
But with that said, if you are using event stream, then the event stream has a maximum capacity of 20 megabytes per message. And the message in event stream is just one line of a record.
Okay.
And that is quite a substantial number. So okay, I haven't seen the ingestion limits being breached yet, and I actually don't know what they are. So
okay, perfect. Thank you.
It also depends on the capacity you have. I'm working here on an F64. If you only have an F2, you will be throttled in your ingestion limitations quite quickly.
Yeah, compression rate's high though. Is the comment coming back?
Exactly. Yes, 9.2. That's quite high. This is the data vendor ID with all the columns and the data types. And here we don't have all these strange data type as we have from the SQL engine. We have long, we have datetime, we have real, string, and we also have integers and decimals. And then we have a specific data type called dynamic, where I can put a JSON object into it and save it there. If I want to just select the data, I can query the table and show any 100 records, and you get it there. So this is the example set with the vendor ID, the pickup datetime, drop off datetime, so forth and so forth. Just a standardized data set with 2 datetime columns. If I want to ingest this into Power BI, well, this is Power BI, and let me just start by using a blank report, and then get data, and then click more. In order to ingest data from real-time intelligence, I need to know my way around the name. That is why I talk so much around Kusto. Search for the Kusto connector and you will find this connector, Azure Data Explorer, Kusto. This also works for real-time intelligence. Select that one. And then I am being asked for the cluster. So what is the cluster? Well, the cluster is found in my, I'm going to close that one, in my event house, in the KQL database. You will find 2 URIs here, the query and the ingestion. I need to query data now, so I need to copy the URI there, and I can paste it right there. I couldn't guess this cluster name, so that's just fine. The database I don't need. And you need to jump down here because import mode on 32 million rows is not going to fly. So I will use direct query. Hit OK. Oops, I need to sign in. Let me sign in. Perhaps I need MFA. I don't know. See what's happening there. Oh, that's fine. Connect. Now I'm presented with my cluster and my database. And the databases are just hash values. That's somewhat annoying, but that is just the way it is around Fabric. So I need to find my tables. This was not the one. This was the one. Here I have the New York City taxi table, and I'll get back to this one, what that is later on. Let me select this table, and I get a normal preview of the data, and I can begin to transform it. Go. And now it moved the screen. Just bear with me there. It should move. It's coming down. There you go. This is my data set, and I can now begin to do things with it if I need to. And in order to show you how to learn the KQL language, when I am in direct query mode, perhaps you know that I can always view the native query. Well, that is also the situation when I'm using Kusto, because I can just transform, add a column, a custom function. No, not the custom function, sorry. A custom column. And I want this to be the year of pickup date. If I can spell. So that must be date.year. Yeah. And then the IntelliSense is playing with me again. There you go. And the pickup time. There you go. Nothing fancy, just a year out of the pickup time, which is a date column. You can see it right there. Hit OK. And then I'm just added. This might not make sense in intelligence world, because out of the date time column, I can always do hierarchies on years, month, and dates. But
Brian,
just to show you. Sorry?
Yeah, sorry, because you said to interrupt. So the question was, we can transform data in direct query mode, which you're showing. And then the comment was, but it has to support query folding. So you have to be able to write it as a SQL, you know, that the KQL engine will understand it.
Yeah, and here you actually don't have to write SQL because the KQL connector in Power BI is extremely good at what you're doing in Power Query to translate that and query folding that back to the engine. It is a very, very few functions in Power Query that does not fold.
Okay, cool. Thank you.
Yeah, again, sure. And then if I view the native query, I can see that this is the query. So if you want to learn Kusto and you know your way around Power Query, then this is the actual way of one of the ways of doing it. And the native query here is just the table name, and then a pipe, and then extend column name equals get year of date time. Then I'm good to go. That's fine. Let me hit OK, and now it went gone. Again, sorry for that. And close and apply. Now Power BI will go and read all the metadata because I'm in direct query mode. It will not. It will only read a subset of the data. And now I have the table here. 32 million rows. And let me show you something. I'll have the total amount by what should we take by vendor ID. Drag and drop. Let me put this into a. There you go. 32 million rows, and I got a query time less than a second. And I can add more things to it if I want to. I can put in a filter there, and I can put in the pickup year. Where was it? There. Go. And then I can begin to filter my data, and then it just works out of the box. Live direct query mode on 31 million rows. I would love to see this performance out of a SQL Server. So now I have showed you how to do that in Power Query, and trust me, it also works in DAX. What about a Kusto function? The next couple of slides are just to help you understand where to find this and what settings to set when you try this at home. So remember, search for the Azure Data Explorer and select Direct Query when you begin to work with all your data. A function is just an equivalent, more or less an equivalent of a stored procedure from the SQL vault. And it adds some sort of different functionality among others, to query data from an outside cluster, and also to query data across databases. And it can also accept parameters, and it outputs typically just a table. Let me run you through this because I will use this function in a few minutes. First of all, I have the create or alter function. Function is just store procedure, and then the name, get syslogs. This accepts two parameters, time window as a string, and bucket as a string. I'll get back to those in a minute. Then I'm accessing an external cluster, so I need to put in the cluster, and this cluster is just help. I'll get back to that also in a minute. The database is sample logs, and the table is raw syslogs. Then I'm filtering the timestamp. The timestamp is a column. Is a column in the database, and I filter that based on the time window. So what is this ago time span? Well, Kusto is very, very generous around time functions. So I can be lazy. I can just say, I want this data 2 days ago. So 2 days in Kusto Vault is just 2 and then a D. Or I want it 1 hour ago, then 1 H, and so forth and so forth. So here I'm filtering, give me the timestamp greater than 1 hour ago, or 2 days ago, or 1 year ago, or whatever, a decade ago. Then I do a small calculations. I do a count. This is just a row count grouped by name. That is also one of the columns. And I name this calculation log count. And then I also group it by a bin of timestamp to time span bucket. What is this? Well, imagine I have 1 year of data and I want to put it into buckets of, no, I have 100 days of data and I want to put this into buckets of 10. So I ask the engine to please give me 100 years, but put it into 10 different buckets. then each bucket will contain 10 days. If I were to put it into 2 buckets, then each bucket will contain 50 days. So I can now begin to group my data as I see fit. So it doesn't make any sense if I want the last 2 milliseconds of data and I want it bucketed in 1 year. That just gives me 1 bucket. Perhaps I want that bucketed in milliseconds. Then just to show you the power of it, then I'm trying to order it by timestamp because ordering in SQL is not funny. To execute the function, I just call it getSysLogs with 5 days as a time window, and the bucket is 1 hour. So then I'll get 24 times 5. That is the amount of buckets I'll get here. If you want to read more, click the link when you get the slides. So back to my engine here, and the function, I've already created it because in any table in Kusto, I have this, I call it a 3-dot-menu where I can do stuff. But in the functions, I can't seem to get access to it. So if you create a function in Kusto, please document it, because yes, of course you can get to it, but it is not easy. I need to do this show function, and then I need to get syslogs, and then I can execute it. Then in this strangely looking JSON object, I get the result of the function that I just created. So please document it. It is way easier to read it from a Word document than to write this function every time I need to figure out what it does. I can use this in Power BI. So get data again from Kusto as a data explorer. Connect. Oops, I forgot to show you that this function, this function calls a cluster outside of my existing cluster. And this cluster is a health cluster. It's a free of charge, read-only Azure Data Explorer cluster where I can do queries on if I don't have any Kusto data available. It is provided by Microsoft. It is free of charge, but I can only do reads. But luckily, the function can do cross-cluster reads. So I'm just executing this function from my own Kusto database. Back to Power BI, the cluster is, there you go. And I'll query again. I think it was the bottom one here. There you go. This is the getSysLogs function. And immediately when I select it, it sees that it accepts 2 parameters, time window and bucket. So I'll just write in 1 year here, and the bucket is 1 month. Apply. Let's see if I get data. It is empty. So let me say 5 years. Apply. Nope. 400 days. Nothing there. This is demo data provided by Microsoft. So let's see if it has data. There you go. 1,000 days. And then it is bucketed in 1 month. Let me show you the buckets. Can I see it here? Scroll. Sorry for the quick scrolling. I want to show you the bucketing. It doesn't show me the bucketing. Well, I will. Oh, it actually does. Sorry. Because 1M is 1 minute. So this is the first bucket. That is the first minute where I have data. And then the second bucket starts. Notice that the minute changes here. So this is my bucketing of my data. Let me load that in without changing it. Hang on it. There you go. Let me close that one. And then I can begin to put in objects here. The name, that's quite fine. I can put in the timestamp that we just saw. Uh-oh, what's happening? This is a standardized error from Power BI. Don't be frightened. It is quite fine because there is a limitation in Power BI where each individual visualization can only handle 30,000 rows in one visual. And as I have not added any implicit measure, it just takes the Cartesian product between timestamp and name. So when I add the, there you go, the log count, I get data. Nope. Why not? Why don't I get data? Did I get too much data anyway? That's it. Let me just quickly transform this one to not that one. Sorry, this one to 100 minutes. Done. Close and apply.
That was incredibly quick, bucketing it from 1 minute to 100 minutes.
There you go. Now I have data. Oh, sorry. Now I have data in buckets, and the first bucket is this one, and then the next comes down here. But if you have worked with Power BI, you also know that I can't expose a query parameter to the end user unless I know this small hack. This is not a hack made by me. It is actually thought out and implemented by Chris Webb, but I will just show you how it works. First of all, sorry?
I've got a question when you're just
sure,
a quick one. Ahead. Can we combine Kusto databases with other sources to create a normal?
Of course you can. Yeah, of course you can. It is just a hybrid model from different sources, and just bear in mind that the results in Power BI will be the query time of the latest arriving data. So if the SQL Server is not as fast as Kusto, then you will have to wait for the SQL Server to finish. Of course, you can do imports. Then you just have to wait for the direct query from Kusto. So that's just the way it is. So yes, you can. Of course you can. Of course you can.
So Chris Webb.
Yeah, thank you. Chris Webb showed us that we can add a blank query, and that blank query is this one. Is this one. Here I'm adding a empty table
nice.
With one column called time window filter as a text. Done.
And he's clever, isn't he?
Yes.
Yeah.
Time window. If I could spell time window, this is the query, and I will add another one because if you remembered, we had two queries.
Yeah.
Both for time window and for the buckets. So I will also add one for the buckets. This is the same query, just with the bucket as the column.
Yeah.
So this is the bucket. And then I need to add two parameters. A new parameter, I'll call this P time window. And this is required. It is of text and it has any value. And the time window was right now 1,000 days. That's fine. A new one, that is the P the bucket. Don't mind my naming conventions, it's just for demo, so I know what to choose here. And again, it is text, any value, and was it 100 minutes, I guess? And hit OK. So now I have two queries, one for time window, one for bucket, and I have two parameters, one for time window and one for bucket. I can then go into the advanced, not this one. I can then go back into the advanced editor of the get syslogs and add my. This is the time window. So this is the parameter of time window. And I can add the parameter of bucket here. There you go. What I did here was just to remove the hard-coded value of 1,000 days and 100 minutes and added the parameters. Done. The same data set is now available to me, and close and apply. But I still can't edit. That is fine. Now I get a potential security risk because I have parameters with free text, and this is a potential security risk around SQL injection. But it's a Kusto engine, and there is no SQL injection in Kusto. It's quite fine. Don't be worried about it. When I have a data model that is only using direct query mode, I have a special option when I go to the data model. If I go into the query of bucket filter and I select the advanced, in the bottom, I have a new functionality. It is not new, but it's just there at the bottom. Bind to parameter. So this was the bucket filter. I can bind this to the bucket. It's fine. Potential security risk, SQL injection, and I can do the same thing with the time window. Now I can actually put these as parameters here, and I can put in advanced filtering. advanced filtering, and oops. And here in this was the bucket filter. So let me see the time window filter. Now we had 1,000 days. Let me see if 800 days works. Apply. Now the data set updates and I get a new data set. Does it also work with 600 days? Yes. Notice that the numbers here are changing, and I'm still working with a lot of data here. This data set has around 1.5 billion rows. I'm not getting the entire data set here, but it has a lot of data. Apply filter, and I can also put it into, I don't know, 300 minutes in the bucket, and then within a second I have the results right here. Imagine now I have given the end user the possibility to do what kind of time window do you want? Just be lazy, write it in free text, and what kind of granularity do you want on your resource set? That is the bucket filter. Imagine doing this in the SQL world or in DAX. I don't know. I wouldn't be able to make this work in SQL anyway. That was the functions, and well, no demo goes today, so you just saw this working.
You are a genius.
Thank you. One thing I want to show you even more is that I can actually do rendering directly in Kusto. I won't go through all of this, but I will just show you that I can actually render things directly in Kusto. So if I go back to my workspace and I remove all of this and I copy the query you just saw and paste it right there, and I run it. Uh-oh. What did I do? Did I do something? 2022? See if this one's...
You tempted the demo gods, Brian.
Yeah, now we got the demo ghost run. There you go. Directly from my query, I can put in the render. I can put in the render function, and I can select what kind of charts I want. There is a lot of charts to choose from. And then I have optional parameters I can put in, like title, XY title, and so forth and so forth. I don't need to put this in, but it just works. And then out of the box, I get a chart at the bottom where I can begin to look at my data, just like if you had a notebook in PySpark. And the same thing actually works with anomaly detection. Anomaly detection is a built-in functionality in Kusto. I don't expect you to understand this query. What I do quite fast, is I just generate 64 rows of data, and I put in a date to them. And then for every first day of the month, I add +20 to a variables of values. And then I try to say, Kusto, please give me the anomalies of this data set and put them in a chart to me and point out the anomalies to me. So if I execute this one, you'll see immediately that I get the anomalies directly in Kusto. I get all the data and the anomalies. If I can zoom in, there you go. Nope, sorry, I'll just do it again. There, the anomalies are these red dots. So anomaly detection in Kusto is just easy peasy. It just works out of the box with a few lines of code, and the anomaly detection is actually just the 3 last lines of code here. So easy peasy, if you know how to do it. These 2 queries are part of the PDF you can download, so you can play around with it. It is a copy-paste enabled PDF, so you can just copy and paste, and this will work. This specific query will work even though you don't have any data, because it generates data as you go along.
Okay.
I hope I have blown your minds a bit now. And the last thing I want to do is talk to you about perspective and patterns. What can we use this for? Well, as I talked to, as I said in the beginning, extremely fast query processing, extremely fast from event to notification from to the end user. And if you want to learn more, then there is a small thing here. I can now begin to build a medallion architecture. The medallion architecture, I just use bronze, silver, gold. You can use whatever names you want. I'm not any kind of biblical around that one. Just name it as you like. Bronze is just the ingestion. That's the first layer from the event stream. This could be what you just saw today. I can then put in a so-called update policy. An update policy is look at it as a trigger on your table. A trigger that listens to what happens in my source table, and then I can do calculations, I can do joins, I can do cleansing, I can do whatever I need to that dataset and put it in a silver layer, in a new table. That's an update policy, and it just runs out of your box. Unless this is prohibitively expensive, why didn't this be a feature of all platforms?
Let's right, talking money.
Yeah, exactly. It cost a bit, this thing here. And then after the silver, I can use, this is just an example, materialized views, which is just, as you know, materialized views, a view that is always updated based on a physical copy of the data from the originated tables, and always ready for you. And all of this I can put in, something went haywire there, I can put in a real-time dashboard. So I'm not promising you anything, but unless you are really, really extremely bad at writing KQL, you will be able to do this within a second. From ingestion to the actual report in Fabric, you can do this within 1 second. If you want to learn more about update policies, I've just released yesterday a blog around update policies. You can read it there, dgbi.blog/update-policies. Then you can read all about update policies. What I did not show you is, perhaps you are, I don't want to learn Kusto. I know my SQL world. Well, quite fine. Let me show you. Select top 100 star from New York City taxi. It also works. You can execute SQL against your KQL database. It is fully capable of accepting whatever SQL query you have. It has a few limitations around some CTEs and some recursive things it cannot do. But if you want to learn Kusto, then begin to write your SQL. And then you might ask, how can I learn Kusto from writing SQL? Well, just write explain on top of this, execute it, and you will see the resource set is actually your Kusto query set, your Kusto select statement. Let me show you. There you go. I can't fit it, but this is my Kusto query that I can now copy and paste, and it will execute. And it will also help me understand the best practices of Kusto, because here I am presented with the project operator, and it selects all the columns from my table. So if I copy, and I paste it, execute it, I get the same results. If I only want some of the columns, perhaps the first two ones, that was too much. Sorry. There you go. Then I can remove it and select them, and then I only have the two first columns. If you know your way around SQL, hit explain on top of it and execute it, and you'll get your Kusto query, and you can begin to learn Kusto that way.
Nice. Next. So we can use it using Power Query or SQL.
Yes. So if you know your way around Power Query and you know your way around SQL, or either one of them, then you can begin to learn your Kusto language quite easy.
Go on costing then.
Cost. Well, it's let me show you.
I know it's going to be expensive, but how?
Yeah. In the stats area, every time you run a query, you will see a JSON object. If I can see that in full JSON, there you go. And this was actually 0 CPU. That was because it was already cached. But if I go here instead, I'm now being quite fast. Sorry for that one. But if I just go machine logs, take 1000, and if I go into the stats and full JSON, then you will, it's still, okay, I've been playing too much with this, so it does not cost me anything. Well, you would be able to see the CPU cost and the breakdown of the cost here, and the cost is equivalent. This is a time-based cost. It's equivalent to 1 compute unit from your Fabric capacity. And for every fabric capacity, you have the double amount of compute seconds for every F SKU you have. Let me try to translate that. If you have an F64, you have 128 compute seconds to use every second. So if this were to take, I don't know, 2 minutes, that's 120 compute seconds. That will then cost me 120 compute seconds out of my capacity. The Kusto engine is highly parallel in its originated state. So you might see that the CPU, that the execution time is not the same as the CPU. The execution time is what you experience as an end user, perhaps a second, perhaps a few milliseconds. But the total CPU time is actually what you pay for it, because it is highly parallel.
Yeah, it makes sense. That makes sense.
Great. Sub 1 second. And as I said in the beginning, on YouTube, I am publishing a video on update policies tomorrow morning at 8 o'clock Danish time. So that'll be 7 o'clock UK time. Where if you don't like to read blogs, you can watch the video. That makes way more sense.
Have you got the link to your YouTube and put it in the chat?
It is right here in my last slide.
And Nis has
thank you, everyone.
Sorry, you can't go yet. We've got a question. How cash works in terms of costing?
Oh, good question. Cash in Kusto is built in the same level as a capacity unit. So you only pay for the cache when your cluster is running. So if you don't run any queries, then the cluster will go into an idle state after, I think it is 30 minutes. Correct me here if I'm wrong. It will be on the learn pages from Microsoft, but it will go into an idle state. And once it is in the idle state, you don't pay for it. When you use the cache or when you begin to query it, then the engine will spin up quite fast, and then you pay for whatever cache you have in the same equivalent amount of the compute units you have available. So,
yeah, Christina said, so within Fabric, this won't cost anything on top of your capacity.
Exactly.
So it's part of your capacity bundle almost.
Exactly.
In a way.
Yes, it is part of your Fabric capacity, and you will be throttled and you will be boosted and all that stuff that we have in Fabric today. And of course, yes, it has a small cost with the storage, which is the same thing as you have in OneLake today.
Yeah.
Like, is that $33 per terabyte per month or something like that? It's minor.
Yeah.
But yes, the compute cost is exactly the same as your existing Fabric capacity.
Okay.
And a small gift, slides are already available in GitHub. So if you want them, just go to github.com/BrianBønk, and you will find them in the report called Slide Decks. Just go into 2024 and the date for today, and you will find them.
But I'm quite blown away, Brian.
Great. That was my intent. So
honestly, that was absolutely brilliant. You are a master.
Thank you. If anyone wants to connect on LinkedIn, just scan this QR code at the bottom right, and then you're good to go. That
was really, really, really good. I mean, it's just fascinating, isn't it? How quick. And then when you added the parameter, and then you were changing the parameters, and it's just responding like that.
Yes, it's blazingly fast. And then I've okay. I'll ask myself a question, then I'll answer it. I'll just stop my sharing here. Typically, I get questions like, "Well, I can just build my data warehouse in Kusto, then I won't need to do anything." Well, yes, you can, but you will also pay for it. The Kusto engine, or the real-time intelligence, is built for limiting time series data's processing from event to end user. imagine that you have a transaction that is made on your GL, and that transaction just needs to be controlled by a controller at the end of the month. You don't need real-time intelligence to do that. That is quite fine to do in a warehouse.
Yeah.
Whereas if the windmill wing is beginning to fall off, then you want something to react, right? That is that is why the real-time intelligence is there. Oh, there's a question.
Yeah, Oliver's
why
got
is
a
it so
really
much
good
faster than
question.
SQL? Oh,
yeah, why is it faster?
It is way faster because the data is underneath the hoods. It is being ripped apart and put into objects called shards. And look at each shard as just a bucket of data. And each shard is then indexed hardly with column store indexes and other stuff, dictionaries and so forth. And then those dictionaries are loaded into memory. So you are actually working more or less with an in-memory technology, even though it is still on an SSD disk. It is amazingly fast because it does querying and retrieving of the data directly from those dictionaries and the index, not the actual data. Yes.
So is there the possibility then that you could use this technology with other the KQL technology with SQL technology eventually?
Yeah, I typically suggest clients to, if they have the need for real-time reporting and this urge for slow processing time, then build a real-time intelligence solution and then offload the data that is perhaps 3 weeks old or 3 months old or something off to a SQL server, off to a lakehouse, to a warehouse in Fabric, and then use your standardized warehouse to do the bulk enterprise reporting. So only keep the small window of data, a tumbling window or sliding window of data in your KQL database, and then just remove what you don't need.
Yeah, so Anthony said, which is, completely agree, monitoring critical sensors needs to be Kusto.
Yes. I have a client that I have an active dialogue with. We are not implementing something yet. They are doing a lot of testing on materials like rubber and springs and all that stuff. And those testings are right now being done on a very, very old piece of software. And I just said, why don't we hook that software up to an event hub? And then we stream from the event hub to the Kusto database, and then we can do real-time reporting. Then they can stop a test if an error occurs more than 5 times, if that's the threshold, instead of waiting 2 weeks for the test to complete, and then they can crunch the data, and then they can do the reporting.
Yeah.
So now they are saving like 80% of the testing time because they can stop the test as soon as they get the error.
Yeah.
So the business case is quite easy to find.
Yes. Yeah, I think I did, but I did that with Microsoft thing when I showed about, I think it was the tires that Ferrari were testing, and when they used to sit and wait for the results to come back, whereas because it was going through a Kusto, they could stop immediately. And
exactly.
Yeah. Brilliant. Well, thank you very much. That was
thank you.
Absolutely
thank you for
brilliant.
having me.
I'll stop recording now. That was awesome. Absolutely brilliant. Thank